Hello, Mr. Choi here. So in this video, I'll be going through acceleration. I'll be introducing to you what acceleration is, and you will need worksheet 2.0 with you. So before we go into what acceleration means, let's classify it in terms of vector versus scalar. So for acceleration, it is actually a vector quantity. This means that it has both the magnitude component and the directional component. So for magnitude, it basically means the size of things. We can assign a number for it. For direction, right, some of you are asking me, some of you are telling me that you are still not very sure what it means by the directional component of a quantity. So for now in secondary school, you have not been introduced to the polar coordinate or the vector coordinate. So it is a little bit challenging for me to illustrate to you, but I will give you some examples. So when we say that there's a directional component to a quantity, it means that uh, the quantity can take on positive or negative number, because in a one-dimensional context meaning that the motion can only go forward or backward. That means we are going on a line, like on a rope. So on a rope, you can only go forward or backward, left or right, right? Or if you want to hold the rope vertically, the motion can only go up or down. So that is what one-dimensional motion is, meaning that let's say I have a ball and I throw it up, the ball will go up and then after that it will go back down, right? So this is what it means by one-dimensional motion. There's only two options, either up or down. So because of that, we use the positive or negative sign to denote the directional component of a vector quantity. But in a two-dimensional case, for example, if you have a player over here and you decided to kick a ball, the ball will go through a parabolic path. Parabolic path is just a technical way of saying this curved path that you see every day when you throw a paper ball into a dustpan, right? So when things go through a parabolic path like that, it is actually moving in a plane, right? You can look at it this way, and it is going through on this plane. So when things are going in this plane, there are different ways of denoting its direction. So for example, if I want to find out what is the direction of motion of this purple dot, right? Then I will draw a tangent to it, and I can actually measure the angle that it make with the horizontal. Horizontal is like a reference point we make, which is this flat line over here. So when we say that there's a directional component to a vector quantity, it means that this particular vector quantity, in this case acceleration here, can be written as two coordinate. So in this case, I am showing you an example of what we call a polar coordinate, which tells you in the upper position the size of the vector, and then after that we will denote the direction of the vector by the angle that it make with the horizontal. So you will only learn about this polar coordinate in JC or in your later studies. For secondary school, this is not required of you, but you need to be aware that vector quantities can be represented by two numbers, one number to denote the direction, one number denoting the magnitude, right? This is the number denoting magnitude, this is the number denoting direction. But for our case, we will limit our discussion to one-dimensional motion, so the direction component is indicated by positive or negative. Yeah. So for acceleration, it is a vector quantity. What does it measure? So basically, acceleration measures the change in velocity over a period of time. So let me explain to you what it means by I measure a change in velocity over a period of time. So let's say I have this object that has acceleration equals to 5 meter per second square. Meter per second square is the SI unit for acceleration. I will explain to you why the weird second square later. So down here you can see that I give you a table to illustrate to you what it means by acceleration equals to 5 meter per second square. So this is the time column, the velocity column, and then this is my acceleration. So throughout the time 0 to 2, my acceleration I keep it as 5 meter per second square constantly, because I want to illustrate to you what it means by a equals to 5 meter per second square. Right, what it means is quite straightforward. It means that over a period of 1 second, my velocity will be changed by 5. So therefore, at time equals to 1, my velocity would have been raised to 5. How about in the second? Well, my velocity will increase by another 5, because that is what a equals to 5 means. So my new velocity will be 10. So in another word, acceleration simply can imply that things are speeding up at a certain rate. So the formula to calculate acceleration is quite straightforward. It is just v minus u over t, where v is the final velocity and u is the initial velocity, and then over time. Yeah. So with this, what you can do now is that you can already fill this up, right? So we can fill it up together. So what is meant by acceleration of 5 meter per second square? Oh, sorry, I forgot to mention why the unit meter per second square. So let's go back to the formula over here. So if you look at the formula over here, uh, acceleration, I want to find the unit for acceleration, right? That's why I give it a square bracket. Equals to, what is the unit for velocity, final velocity? Well, it is measured in meter per second, right? How about u? Right, u is also measured in terms of meter per second. How about time? Time is measured in terms of seconds, right? So if I have something meter per second, subtract by something that is meter per second, I am going to get back something that is in meter per second, right? So do not confuse with oh, if I have x minus x, I should get 0. This is not a value, this is just unit. So if you have 4 orange minus 2 orange, you are still going to get something orange, right? Like 6 orange minus 3 orange, you're still going to get some orange. Yeah. So you will have something like that. Then here you will see that you have meter per second divided by second. So meter per second divided by second simply means meter per second square lor. So that is how you derive the unit for acceleration. So let's get back to this. What is meant by acceleration of 5 meter per second square? Well, it means that the velocity will increase by 5 meter per second every 1 second. Now take note of a few things. Number one is I didn't use the word speed here. Why can't I use the speed? Why can't I use the word speed here? Well, the reason is because for your acceleration, it is a vector quantity. So down here, you cannot use speed. And that is because your speed is scalar, right? If you use a scalar, right, if you say something like it means that the speed will increase every second, you are using a scalar quantity. Speed is a scalar quantity. So how can you produce a vector quantity, which is acceleration, with a scalar quantity, right? It cannot happen, right? The next thing that I want you to pay attention to is that, do you notice that the unit here is meter per second square, but I use meter per second here, right? There is a square over here, but there is no square over here. Do you notice? Yeah, why? That is because when you are saying increase by 5, this 5 over here refers to velocity, and velocity has a unit of meter per second, not meter per second square, right? So how do you get the square? How do you get the meter per second square? Because that's what the question wants, right? That is because you quantify it by, oh, this increase of velocity happens every 1 second. So you are saying that this is actually a per second thing. So in the end, you will still get back 5 meter per second square. Okay. Formula for this, well, you can get back this, yeah. And as for question 6 to 8, you can try on your own, right? Final speed, starting speed. I use the word speed so that you are more familiar with it, but to be very precise, this should be final velocity. Okay, so that you can use it in your in your formula. Then there are some things that you may want to take note. Complete stop, what does it mean by complete stop? Well, complete stop simply means that your velocity is going to be 0. Yeah. uh, must your answer be positive? Well, acceleration is a vector quantity, so you can expect some of this to be in negative value. Okay, so do try. So things like this, start from rest. Well, start from rest meaning that your rest means velocity is 0, right? So do try out question 6 to 8, yeah, and then key your answer into the SLS to confirm your understanding. Yeah, then after that watch the next video.